Hi class, welcome to our grade 8 mathematics lesson for this week. Our topic for today is illustrating and verifying a relation and a function. Let us begin. For our learning objectives, we have the following. The first one is at the end of the lesson, you should be able to illustrate a relation and a function. And also, you should be able to verify if the given relation is a function. Now, let us define some terms. The first one is relation. Now, what is relation in mathematics? A relation shows the relationship between the input and the output. Or simply, we can define a relation as a set of ordered pairs. From our previous topic, we were able to learn what an ordered pair is. So I hope you're already familiar about this one. Now, let's have some examples on relation. In here, we can see that we have a table of values. We have the variable x and we have the variable y. So for the variable x, we have the given elements 1, 3, and 5. And for the variable y, we have the elements or in outputs 1, 9, and 25. So as we can see, we have three ordered pairs in this example, which are 1, 1, 3, 9, and 5 and 25. By definition, a relation is simply a set of ordered pairs. So we can say that this illustration is an example of a relation. Next, for this example, we can see that we have a set of ordered pairs. So we have the ordered pair 1a, 1b, and 1c. So we have three sets of ordered pairs in this example. So this one can be considered as an example of a relation as well. Now, we have to remember that a relation can be represented or illustrated in different ways. The previous examples that I've shown you a while back are already an example of those ways. So the remaining ones will be further discussed later. So actually, a relation can be illustrated or expressed using a table of values, or it can be expressed or illustrated using a set of ordered pairs, or you can also use a mapping diagram, and lastly, we can use graph. Now let's have an illustrative example. Here, Kenneth gets 2 points for every activity that he accomplishes. So that is our problem. Now, we are tasked to illustrate the given relation using different ways, those ways that I've mentioned a while back. But before we do that, we have to express this problem into an equation. Now, how do we do that? Going back to our problem, we can see that Kenneth gets 2 points for every activity that he accomplishes. So meaning, for us to express this problem into an equation, we have to think of a variable which will represent the number of activities that Kenneth accomplishes and the total number of points that Kenneth gets. Now, we can arrive at this equation. Okay? So to explain this better, the x is used to represent the number of activities Kenneth accomplishes, and y is used to represent the total number of points Kenneth gets. Okay? There. So x will represent the number of activities Kenneth accomplished, and y will be the total number of points he gets. Now, where did we get this 2 from? So going back to our problem, we can see that for every activity he accomplishes, he gets 2 points. That is why 2 will be multiplied to our variable x. Okay? Now, again, we were tasked to illustrate this problem or relation into an illustration. Now, how do we do that? Using a table of values. Using our equation that we were able to arrive at, which is y equals 2x, we just simply set the value of x into a certain value. For example, Kenneth was not able to accomplish any activity yet, so that is why we can set our value of x to 0. Now, using our equation, which is y equals 2x, we just simply substitute the value of x to 0. That is why we have y is equal to 2 multiplied by 0. Now we know that 2 times 0 will give you 0. That is our answer for the y. So if x is equal to 0, then our y is also 0. To represent our answers or our values using a table of values, we just simply have to construct one. So we have the table of values which has the variable x and the variable y. So since we have already set our value for x as 0, we just have to simply put that value here in this box. And since we were able to compute the value of y using that value of x, we just simply put our value of y in this box. That is why we have these values. So meaning, if Kenneth did not accomplish any activity yet, he gets no points for that. Okay? So what if Kenneth was able to accomplish one activity? So how do we do the computation? Same method that we used. So for example, Kenneth was able to accomplish one activity. So using our same equation, we just simply substitute the value of x, which is 1 here. So that is why we have the equation y is equal to 2 multiplied by 1. So 2 times 1 will give you 2. So if Kenneth accomplished one activity, he will get 2 points for that. So since we have the values of x and y, we just simply input our values in this box. That is why we have x is equal to 1 and y is equal to 2. Now, what if Kenneth was able to accomplish two tasks? Same computation. So we just have to use the same equation. So if x is equal to 2, we just simply substitute the value of x here. So 2 multiplied by 2 will give you 4. So for two activities that Kenneth accomplished, he will get 4 points for that. So we just simply input our values in this box. Okay, so actually our table of values can still go on depending on how many activities Kenneth accomplishes. So we just have to use our same equation and we just simply follow the same computation. That is how we represent that problem using a table of values. Next, let us represent that same values using a mapping diagram. So we just have to simply construct this diagram wherein the values of a variable x will be placed here and the variable y will be placed on this side. And all the same elements that we used, which are 0, 1, and 2, which are the inputs for y, will be placed under the variable y. And all the outputs that we were able to compute will be placed under the variable y. Now, since we know the relationship or the relation between those values, we can construct the arrows now. So we know that 0 is related or paired with 1, and 1 is related or paired with 2, and 2 is related or paired with 4. So that is how we construct a mapping diagram. We just have to be careful where the arrow is pointing to. Next, using those same values that we were able to use and compute, we can illustrate the problem using a set of ordered pairs. So how do we do that? We just simply need to construct a pair of braces, and inside those braces, we just simply input our pairs or set of ordered pairs. So we know that our first ordered pair is 0, 0, The second one is 1, 2, and the third one is 2, 4. Take note that the values highlighted in green are all the elements or inputs for x, and all the elements or values highlighted in orange are the elements for y. So this is how simple to illustrate a relation using a set of ordered pairs. Lastly, we can illustrate our problem using a graph or by graphing. Now, we have learned in our previous topic how to graph or plot first a certain point on a Cartesian plane and then connect those points for us to construct a graph. Now, using our same sets of values, we have 0, 0, 1, 2, and 2, 4. So we have these three ordered pairs. Now, we can treat these ordered pairs as points, which we will be plotting on our Cartesian plane. So notice that our elements highlighted in green are the elements for x, and all the elements highlighted in orange are the elements for y. Okay? First, we have to construct a Cartesian plane, or if we have a graphing paper, you have to use that. Okay? So you have to construct your Cartesian plane first, or your rectangular coordinate system, and after that, we just have to simply plot the points or ordered pairs that we have. The first one is 0, 0, which happens to be our point of origin. So we just simply have to plot that one here. So that is our first point, 0, 0. Okay? Next, our second point is 1, 2. So positive 1 for x and positive 2 for y. So we just have to simply intersect those, find the intersection, and that is where we plot the point. So point 1, 2 lies here. Next, our third point is 2, 4. So we just have to simply plot that point on our Cartesian plane. So positive 2 for x, positive 2 for y. So positive 2 for x, positive 4 for y. The intersection is here. So that is where we plot our third point. So once we have already plotted our 3 points, we just have to simply connect those points and form a graph. So the graph form will be the graph of our equation that we used, which is y is equal to 2x. So those are the different ways on how to illustrate a relation. The first one we use is a table of values, and then we use a mapping diagram, a set of ordered pairs, and lastly, we use this one, graphing. Okay? A while back, we were able to define what a relation is. Now, let us define a function. So, what is function in mathematics? Function is defined as a relation with one output for each input. Meaning, for a function to be a relation, an input should only take one output. So, it's 1 is to 1. Okay? Now, let us have to remember that all functions are relations, but not all relations are functions. Later on, we will be able to understand why is that so, why not all relations are functions. So how do we verify if a given relation is a function or not? So for us to consider a relation as a function, there should not be any two separate ordered pairs with the same first element. So to make it simpler, all the first elements, so what are those first elements that we're referring to? The first elements that we're referring to are the elements for x. Those are the input values. So in here, it says that no two separate ordered pairs with the same first element, meaning all the values for x should be different. No repeating value. For us to understand this one better, we can actually know how to easily recognize if the given relation is a function by mere inspection. So how do we do that? First, we have to know that all x's must be different. meaning all the values for x should be different. Also, every element in x should be related to y. If you recall our previous slides, I've shown you a mapping diagram. It shows there that all the elements are related to y because all the arrows are from x are pointing to y. So every element in x is related to y. And to know this one better by mere inspection, we just have to focus our eyes on the value of x only. Because for the values of y, regardless if the values are different or if there are identical or the same values, it does not matter. We only have to focus our eyes, or our concern is only on the values of x, whether the values are different or if there are identical or the same values. So let us have some examples. Let us try to verify if the given relation is a function. Let's have the first one. In here, we can see that we have a table of values. We have the given variable x and the given variable y. So for the variable x, we have the elements 1, 3, and 5. And for y, we have 1, 9, and 25. And using our condition, we just have to make sure for this one to be considered as a function, we just have to make sure that all the elements of x are different. And we were told that we just have to focus on the values of x. So since we can tell that 1, 3, and 5 are different from each other, and all the elements of y or x are related to the elements of y, we can say that this illustration is a function. Next example, we have another table of values. In this case, the elements of x are highlighted in blue and y are highlighted in red. So again, we just have to focus our eyes on the values of x. So we can notice that one element or one value is repeated because we have 4 here and we have another 4 here. One condition that we have to follow is that all the elements of x should be different. If there's one repeating value, then we cannot consider this illustration or relation as a function. Therefore, this example is not a function. Next, let us have an example using a mapping diagram. In here, we have the variable x and y, and all the elements under x are placed, or all the elements of x are placed under x, and all the elements of y are placed under y. So we have 0, 1, 2, we have 1, 2, 4. Again, when we are treating this one, when we're using a mapping diagram, we just have to be critical on the arrows, where the arrows are pointing to. In this case, our input 0 is paired or related to 1 only, and our input 1 is related or paired to our 2 only, and the input 2 or element 2 is paired or related to 4 only. So one input is paired to only one output. All the inputs that we have, or the elements under x, are paired to only one output. Therefore, we can consider this illustration or relation as a function. Next, let us have another example using the same illustration, which is mapping diagram. In this case, under the variable x, we have the elements 3 and 5. And under the variable y, we have the elements a, b, and c. Now, let us find the relation between those two variables. We can see that 3 is related and paired to a only. However, 5 is paired or related to b. At the same time, it is also paired and related to c. Since one output is related to more than one outputs, we cannot consider this one as a function. Okay, because one output or one input should be only related to one output. Therefore, we cannot consider this one as a function. This example is not a function. Now let's have another example using a set of ordered pairs. Again, if we are given a set of ordered pairs, we just simply need to focus our eyes on the values of x. All the values of y or x are written first. Okay? So since we see that all the values of x are different, which are 1, 2, and 3, we can say that this example or illustration is an example of is a function. Next, let's have another example using another set of ordered pairs. In this case, we can see that the elements for x are identical. So we have a repeating value for x. We have 1, 1, and 1. Since the values of x are identical, because we have to remember that all the values of x should be different, it breaks our condition. Therefore, this illustration cannot be considered as a function. Now let's have another example using a graph. In this illustration, we can see that we have a graph which is colored blue. For this one, we just have to, for us to check if this graph or relation is a function, we just simply need to construct a vertical line which passes through our graph. And then, we can see that there's a point of intersection between the graph and the line or the vertical line that we constructed. If there's only one point of intersection between the two, we can verify that this one is a function. Again, if there's only one point of intersection between the vertical line that we constructed and the given graph, we can consider the relation as a function. Therefore, this example is a function. Let's have another example using another graph. In this case, it is highlighted in or colored blue. So same method that we have to use, we just simply need to construct a vertical line which passes through our graph. However, if you notice, our vertical line intersects with our graph here, and at the same time, it intersects on that point as well. So it means that our vertical line intersects with our graph twice. Therefore, we cannot consider this one as a function because for a graph to become or for a relation to become a function, it should only be intersecting once. There's only one point of intersection. Since there are 2 points of intersection, we cannot consider this one as a function. In last example, we have this graph. Same method that we used. Vertical lines should be drawn which will pass through our graph. And just like our second example, the vertical line passes through or intersects to our graph twice. Once here and then another here. So there are 2 points of intersection. Therefore, we cannot consider this one as a function. This is not a function. Okay? So with all those pointers, highlights, and examples, I hope the lesson is clear. But for us to verify if the lesson is clear, we just have to make a quick recap or a quick review. So we have learned that a relation is a set of inputs or outputs, or simply it is defined as a set of ordered pairs. And we have learned as well that a function is a relation with one output for each input. And also we have learned now better that all functions are relations, but not all relations are functions. And how do we consider again if a function is a relation? So we know now that a relation is a function if there are no two separate ordered pairs with the same first elements. Meaning all the first elements or all the values of x should be different. And for us to easily recognize a function by mere inspection, we have known that all the values of x or all the x's must be different. And we have learned as well that every element in x should be related to y. And of course, we just have to focus our eyes on the value of x only. So that would be the end of our lesson for this day. So I hope you have learned a lot from this discussion, which is illustrating and verifying a relation and a function. So I thank you for listening for this discussion, and may God bless us all. Thank you.